Hello everyone. Today we're going to do Chemistry Notes Part 4, Ions and Ionic Charges. We're returning to this well because ions and ionic charges are fairly tricky. So the first thing that we need to remember, very important, is that your proton number is equal to your atomic number. That is always true in atoms and in ions. Let's zoom in a bit. There we go. Okay, very important. So what's changing to make things different in your ion versus your atom is that the electron changes, the electron number. So in ions, the electron number changes. Now remember that electrons have a negative charge. They have that 1 minus, and that protons equal a positive charge, 1 plus. Okay? So what that means is if you have more protons than electrons, what is your charge going to be? I'm going to give you a second to think about that. If you have more protons than electrons, you have more of this positive charge than a negative charge, what are we going to have? Okay. What you are going to have is a positive charge overall. Because every time I have a 1 plus and a 1 minus together, say if I have 10 positive and 10 minus, overall my charge is going to be 0 because every plus is going to balance with a minus. But as soon as I have extra pluses that don't have a minus to balance it out, the pluses win and I'm going to have a positive charge overall. So more protons than electrons equals a positive charge. Okay, let me zoom out a bit. Oop. Okay, but just as often I have more electrons than protons. So if I have more electrons, that means I have more minuses than I do pluses. And any minuses that aren't balanced out by a plus mean I'm going to have a minus charge overall. So this means I'll have a negative charge. Okay, very important. That being said, we're going to look at some examples like we started to last week. How do you use your periodic table to draw a Bohr model? So I'm going to zoom back in a bit. The first thing we're going to do is you need to understand when you're looking at your ionic table, not all of the ionic charges are written as simply as you would hope. You'll see like scandium is written as 3 plus, that's pretty clear. Calcium is 2 plus, but then potassium and everything in that first row of alkali metals with potassium just has a plus. What plus means is 1 plus. It has a charge of 1 plus. So if you printed your periodic table, I would encourage you to write a little 1 in front of it. Again, the numbers go before the plus and minus sign because this is a universal configuration. Whether you're speaking English, French, Japanese, Greek, scientists across the world have decided the plus and the minus sign go after because that is a convention you see in other languages. Same goes on the other side of the table. Nitrogen 3 minus, oxygen 2 minus, fluorine, and everything in that column of halogens with fluorine has just the minus sign. So I would encourage you, if you've printed it off, write a little 1 in front of it. So I'm going to write that down just so we know for later. Plus equals a 1 plus ionic charge. especially with the minus sign. People sometimes forget just because it looks like it might be an underscore or something other than a subtract sign. So you might want to write that in for yourself. Okay, that being said, our first example is going to be sodium. So if we look up sodium, we see that sodium has 11 as its atomic number. It's got a charge of 1 plus, and it's got an atomic mass of 23. So 11, 23, 1 plus, and I would encourage you to get in the habit of writing that 1 there, just so you, like the periodic table, cannot get misconstrued. So we're going to have our proton, neutron, and electron number. Okay, proton is going to be the atomic number because they are always the same. Neutron is always the atomic mass minus the atomic number. So in this case, 12. And our electrons, we start with that atomic number. We start with the 11. And then we are going to do the opposite of the ionic charge. So opposite of the ionic charge is not 1 plus, but 1 minus. The reason why it is the opposite is because the electron charge is negative. So if we have an overall positive charge, that means we've lost electrons, and we have some protons that do not have a matching electron. So opposite of that gives us 10 overall. So this 10 is very important to us. This tells us what the Bohr model configuration is going to look like. Because if we have 10 electrons, when we're looking at our periodic table, sodium, the ion, does not look like the atom. The atom, we know, is going to have 3 shells, and it's going to have 1 electron in that 3rd shell because of where it's placed for the atom. But the ion doesn't have 11 electrons. It has 10. So electron-wise, it is going to look like neon. So 10 tells us what the Bohr model looks like. Atomic, let me move down a bit. Looks like atomic number 10 or neon. Okay, so taking another glance back at neon. Neon's in the 2nd row, so that means it's going to have 2 shells, and it's in the last column. It's going to have 2 full shells. As I told you last day, most ions are going to have a full shell. That's the goal. So protons, neutrons, 11 protons, 12 neutrons. Remember that first nucleus. Let's go out. First nucleus doesn't have any electrons on it, very important. First shell then has 2 electrons up at the top. Some of you lost marks because you kept placing them, one at the top, one at the bottom. Both at the top, please. Then that 2nd shell, we know it's going to be full. So if you wanted, you could count it out as you go and make sure that you have the full 8. So there's 4, 5, 6, 7, 8. Or you could also be lazy and place them at a pair at a time because you know that shell is full. So that's sodium as an ion. Next, we are going to take a peek at chlorine. So chlorine's on the other side of things. So if we take a peek at chlorine, it's got an atomic number of 17, atomic mass of 35.5, and an atomic number of -1. Again, that little minus sign can be confusing without a 1 in front of it. So I'm going to write that down. 17 We never write it as a decimal form. We're going to write it rounded, so this becomes 36 and 1 minus. So we get protons, neutrons, and electrons. Our proton number is, of course, the same as our atomic number, so that means that we are going to have 17. Neutrons, we take our 36 minus 17, and we get 19. And our electrons, we start with 17, and then we do the opposite of 1 minus, so we add 1, and we get 18. So this means it's going to look like our atomic number 18. So for us, in this instance, we look for atomic number 18. Atomic number 18 is argon. Okay, so again, as far out as it can be, means it's going to have a full shell, but this time it's going to be 1, 2, 3 full shells when we draw it. So, I'll zoom out a bit for my atomic model. Protons 17, neutrons 19, never putting anything on that nucleus. First shell, 2 electrons at the top. Second shell maxes out at 8. Third shell also maxes out at 8. And there we are. Perfect. On this note, I have noticed some of you struggle to remember how we know that 8 is the maximum. Remember, we always know the maximum in a given shell by counting across your periodic table. So that first row only has hydrogen and helium. Remember, hydrogen is repeated twice, so there's a maximum of 2 in that first shell. Second row, 1, 2, 3, 4, 5, 6, 7, 8. Maximum of 8 in that second shell. 1, 2, 3, 4, 5, 6, 7, 8. Maximum of 8 in our third shell. And then our fourth shell is the first one that spans the entire distance. Because of this, if you're lazy, you can use the actual column number. So it has a maximum of 18. And this year we won't be going beyond the first 4 rows. Okay, so quick little recap, what's important? Remember that your electron number tells you what your Bohr model is going to look like when you are in ions. Remember that our proton number is always equal to the atomic number. That doesn't change. And remember, if we have more protons than electrons, we're going to have a positive charge overall. More electrons than protons, negative charge. Okay, have a good day.